A conjunction of one or more disjunction or one or more sentences of letters. Okay, for example, we have P or Q. Okay, and then okay, we have P or Q and R or Q is a disjunction of the conjunction. Okay, wait, Okay, for example, we have okay, we have P and Q, and then we have R and or S. Okay, and then we have disjunction. Okay, here O, and then we have O over N. Okay, we have O here, and then we have N. Okay, okay. And then P O R and P O R, which is itself is conjunctive. Conjunctive. Normal form, as you can see, because it is a conjunctive string of one or more disjunction or more sentences, letters, and truth condition for both of these will be the same. Okay, and then you can also go by the truth table. Okay, as you have learned in discrete structure. Okay, this one either uh, P is true, uh, okay, or false. P or Q is only true if Q is true. And again, assuming P is false, if only if that P is disjoint here. Okay, P and Q. Okay. Okay, and then CNF example. When I have to close first and then open again. Okay, this one is step by step. We put A or B implies that C and D into conjunctive normal form by using the equivalences theorem. Okay, first we do the implications, and then after that we do the De Morgan law, and then distributive law twice, and then lastly is associative law. Okay, here, okay, implication. And then we do the we put the negation into the bracket, okay, for the De Morgan law, and then we go by the associative law, okay, for 2 and 3, and then finally we have the associative law. Okay. And then another example, reduce the conjunctive normal forms and for the formula. And then for the solution, we go by okay, negation first. We negate. Okay, and then here we go by the De Morgan law. Okay, negate P and negate Q, or negate R or negate F, and then we have negation normal form NNF to remove the negation, and then we got P and negate Q, okay, or negate R or negate S, and then finally we go by the associative law. Okay, we got P and P or negate R or negate S, and uh, negate Q or negate R or negate S. Okay, this one is example one. Another example uh, is like this. Okay, we have negate P implies Q implies Q implies negate R. Okay, reduce the SNF formula by using the De Morgan law and negation normal form. Okay, we put the negation here and put the negation negate P O Q, and then we have O here negate Q or negate R, and then we negate the negation normal form NNF. Then finally we get negate P or, okay, this one is associative, okay, associative law from N conjunction. We got a disjunction, and then uh, okay, or negate R, and then we have N here, okay, negate Q or negate R. Okay, please to convert the following formula into CNF using the equivalent transformation. Okay, we have A, we have B, and then we have C, and then we have D. Okay, for transformation, okay, normally we go by the distributive law first, and then we go by the De Morgan law. Okay, and then we go by the NNF negation normal form. Okay, and then we go by the associative law, associative distribution law. Okay, for number 3 and 4. Okay, this one is for the exercise. Exercise, you should go upload to Padlet. Please upload to Padlet. Okay, do you have any questions so far? Is it okay? Okay, and then we continue a little bit. I think this one we continue next week. We go by the scholarmization. Scholarmization is the continuation for the uh, CNF, conjunctive normal form. After that, we need to scholemize. Okay, scholemize the sentence. Okay, by using the clausal form. Okay, next week lah. We seen this one. Okay, class. I think that's all for today. You should refer to my YouTube. My YouTube.